Okay, so in this question, the joint density function of x and y is given to be ay square for 0 being less than y less than mod of x less than 1, and this joint density function is 0 otherwise. So this condition for y and x can be given by this graph. Here y is equal to x and y is equal to minus x. So the first question that is asked is find a. Assuming that fx comma y is a valid joint density function, that means we have to double integrate it on x-axis and y-axis from minus infinity to infinity, and obviously the area is 1. So once we integrate it, we get something like this, and we know the area is 1, so taking 6 to the other side, we get a is equal to 6. Now the second question asks us to find and draw the marginal density function of f of x. Now we know that the marginal density function for any random variable can be found by integrating it over the given condition. In this case, y goes from 0 to mod of x. So if we integrate it from 6y square dot dy, we get 6y cube by 3 is equal to 2y cube for 0 to mod of x is equal to 2 mod of x cube. Now this can go from minus 1 to 1. So if we plot it over the graph where x-axis is f of x and x-axis is f of x and y-axis is this thing, so we'll get the graph something like this. Now the next question is to find and draw the marginal density function of f of y. So we will apply the similar logic we applied in the last question. So if we integrate it from minus infinity to infinity of the 6y square, this is the joint density function over dx. So we'll get something like from minus 1 to minus y 6y square dx plus y to 1 6y square dy, which is nothing but 6y square into x, and this goes from minus 1 to minus y because of the limits of this integral, plus 6y square dot x, which goes from y to 1. So once we integrate that, we will get something like this: 12y square minus 12y cube. And if we plot it with x-axis as y and the y-axis as f of y, we will get the maximum value. The graph peaks at y is equal to 2 by 3 and the value we get is 16 by 9. So the next question is we have to find and draw the conditional density function of f of y given x. So we know that the formula for y given x is the joint density function divided by the marginal density function of x. We know the joint density function is 6y square and the marginal density function of x is 2 mod of x cube, so 3y square by mod of x cube. So once we plot this with the, we'll get something like this with the x-axis as value of x and the y-axis as f of y given x. Next question is we have to find and draw the conditional density function of f of x given y. So we apply the similar logic. F of x given y is nothing but f of x comma y by f of x. So 6y square by 12y square into 1 minus y. So we cancel 6y square from the numerator and denominator. We get 1 by 2 to 1 minus y. So if we draw it with the y-axis as f of x given y and the x-axis as y, we get something like this. So in the next question, the first subpart asks us to find the estimated value of x. So we know the formula, minus infinity to infinity x f of x dx. So we just put the limits, and we know the marginal density function of x, which is 2x cube. So once we put everything in place, we'll get something like this. But since this is an odd function, we'll get the integral value 0. Now next, estimated value of y, which is similar to the last question. We just integrate it from minus infinity to infinity, but the limit extends only from 0 to 1. So 0 to 1 y, 12y square into 1 minus y dy, and once you integrate that, you'll get 12y power 4 by 4. Now this part goes from 0 to 1, so these are the limits here, and the other thing is minus 12y power 5 by 5, which also goes from 0 to 1. So this is nothing but 12 by 4 minus 12 by 5 is equal to 3 by 5. Now next, expectation of xy. So we apply a similar logic, but in place of x we put xy, and in place of in this place we put the joint density function of x and y, that is 6y square, and this is a double integral for x going from 0 to y going from 0 to mod of x, and x going from minus 1 to 1. So once we integrate it with respect to y, we will get something like this, and then we integrate it with respect to x, we should get something like this. So since it's an odd function, we should get it as 0. Now the next is estimation of y given x. So we know y given x can be given by this formula, y into f of y given x dy. So we can directly find the limits going from 0 to mod of x, and y into 3y square by mod of x cube into dy. So this becomes 3y cube by mod of x cube, and which is nothing but 3y power 4 by 4 mod of x cube is equal to 3 by 4 mod of x. Now next is estimated value of x given y. So similar logic, we integrated x into f of x given y. Now we know the limits go from minus 1 to y and y to 1, this value. So we should integrate x by 2 1 minus y dx from minus 1 to y, and add it with another integral of the same thing from y to 1. So we should get something like x square by 4 1 minus y. These are the limits, minus 1 to minus y, and x square by 4 1 minus y again, and the integrals from y to 1. So once we substitute all the values and find the summation, we should get it to be 0 again, because it is again an odd function.